Okay, so in this video, let's understand what the cosine distance and the cosine similarity are. Okay, um, this is a very, very important distance measure, cosine distance. It's used extensively in data science and machine learning. And yeah, so let me first, before we even dive into what cosine distance is and how is it different from Euclidean distance, let's understand the relationship between distance and similarity. Okay, if I have distance over here, if I have similarity over here, the relationship between distance and similarity is such that, if my distance increases between 2 points, let's say those 2 points are, x1 and x2, x1 and x2. So if my distance between the points increases, the similarity between them decreases. And if my distance between the point decreases, my similarity between them increases. Okay? So this is the relationship between distance and similarity. So I can write this as if 1 minus cosine similarity of x1 and x2 is equal to cosine distance cosine distance of x1 and x2. Okay. So this is the relationship between cosine similarity and cosine distance. So how do you measure cosine similarity? I'll just draw this in some one example here. So I have two data points which have two features. The first feature is f1 and the second feature is f2. And let's say I have the data point x1 over here and I have the data point x2 over here. So if I have to measure the Euclidean distance between them, I try to get the shortest distance between these points, right? The shortest straight line between points x1 and x2, that's my Euclidean distance. The cosine distance is different. Okay, so the cosine different distance is basically, if I this is the origin, this is a point 0 comma 0. So the cosine distance between x1 and x2, sorry, the cosine similarity, I'm sorry, this is not the cosine distance, it's a cosine similarity. The cosine similarity between the points x1 and x2 is given by the cos of the angle between them. Okay, so if the angle between x1 and x2 is theta, the cos of that angle will give you, if the angle between x1 and x2 is theta, the cos of that angle will give you the cosine similarity of the points x1 and x2. So we have 1 minus cos x1 and x2 equal to cosine distance. Okay. Now, you know that cos varies between -1 and 1, right? That's the range of the cosine function. It varies between -1 and 1. So the cosine distance basically varies between 2 and 0. The cosine distance, because the cosine of the two data points x1 and x2, because cosine as a function varies between -1 and 1, the cosine distance will vary between 2 and 0, right? Because when you have -1 over here, it becomes 2, and when you have 1 over here, it becomes 0. So so it's easy to see how, like it's easy to see that if the cosine distance is 0, the points are similar to one another. So the difference between Euclidean distance and cosine distance is that, Euclidean distance finds the straight line measure, straight line distance between the points x1 and x2. But cosine similarity finds the angular distance between x1 and x2. Let's say I have 2 points, 3 points, x1. I have another point similarly in the straight line of x1, x3, and then I have a point x2, right? The cosine distance, this is feature 1, this is feature 2. The cosine distance for x3 and x1 would be cosine distance for x1 and x3 is equal to 1 minus cos of 0. The cos of 0 is 1, right? So this is 0. And the cosine distance between x1 and x2 would be equal to 1 minus cos theta. Theta is some value greater than 0. So this will be greater than 0. Okay. So when you look at this, you can observe that even though there is some Euclidean distance between x1 and x3, the cosine distance between them is 0. So the points that lie on the same angle uh, in a d-dimensional plane would be given a 0 distance using cosine distance, and the points that lie at which have some angle between them in a d-dimensional plane would have a distance between them greater than 0. So this is where cosine distance varies and is different from Euclidean distance. So now let's understand how the cosine distance is related to the Euclidean distance. How can we actually relate the cosine distance to the Euclidean distance? So first off, if you have two vectors, any data point is basically a vector, right? Because it will have, if it's x1, it'll have feature 1, feature 2, all the way to feature m. In this case, it has only two features, but generally, every data point is a vector if it has m features, or in this case, it has only two, but in general, every data point is a vector of some number of features, right? So how do you find the cos of the angle between them? How do you find cos theta of the angle between them? The formula from linear algebra is x1 dot x2. This is the dot multiplication. This is from your linear algebra upon the magnitude of x1 and the magnitude of x2. Okay, magnitude here is nothing but the L2 norm, right? Because if you have features, you would just take xf1 plus xf2 the whole square all the way and underroot it, right? So that is that is the L2 norm, right? So that's why the magnitude is nothing but the second norm of this, correct? And this is the dot product. This is the dot product. You just multiply the ith vector with the ith vector and add the jth vector with the jth vector. That's all. That's the dot product. Now, if your vectors x1 and x2 are unit vectors, what does that mean? If x1, if the magnitude of x1 is equal to the magnitude of x2, if the magnitude of both these vectors is equal to 1, then that means that these vectors are unit vectors, correct? In that case, the cos theta, or the angle between them, or the value of the angle or the cosine value of the angle between them, is given by x1 dot x2 upon 1 into 1, which is just x1 dot x2, right? This is the value of cos theta if they are unit vectors. So now, how do we equate the Euclidean distance with the cosine similarity, right? Now I'll just use some linear algebra here, and I'll try to find a relationship between Euclidean distance and cosine similarity. So I have the two vectors x1 and x2, right? x1 minus x2, the magnitude of them, the whole square, is basically x1 minus x2 transpose into x1 minus x2, right? This is from linear algebra. To multiply the two, these are basically vectors. So if you have to multiply them, you have to multiply the transpose of one with another. So this can be written as magnitude of x1 square plus magnitude of x2 square minus 2 into x1 transpose x2, right? This is just your simple identity, algebraic identity. Now, if x1 is equal to, if the magnitude of x1 is equal to the magnitude of x2 is equal to 1, this equation can be written as 1 plus 1 minus 2 x1 transpose x2. Okay, so that's 2 minus 2 x1 transpose x2, which is equal to 2 into 1 minus x1 transpose x2, right? And we know from here we know that x1 dot x2 is basically what x1 transpose x2 is, right? That is the dot product. So, and we know from here that this is equal to cos theta. So we can say that the Euclidean distance between x1 comma x2 is related to the cosine distance as 2 into 1 minus cos theta. Now this is the cosine similarity. Okay, this is the cosine similarity, right? Because from the formula we know that 1 minus cos theta is equal to the cosine distance. So it's equal to 2 into cosine distance. Okay, so this is how you relate the Euclidean distance to the cosine distance. And the cosine distance is actually very important. It's used almost in every application of data science. Yeah, so I'll stop the video here and I'll see you in the next video.